Hello everyone, my name is Ankit Verma and today we are learning increased accuracy of classifier. Classifier is also called model or algorithm. In the diagram we can see that we have training data from which we train the classifier and they give the prediction. To increase the accuracy of classifier, model or algorithm, the first technique is data pre-processing. Data pre-processing means removing noise and inconsistencies from data before processing. Here pre means before, processing means when we process the data. So before processing, so before giving to the model, first of all, we are going to remove the noise and inconsistencies from the data. The techniques used for data pre-processing are the first one, handle missing data. Here, if some data is missing, we handle it. Second is outlier detection and removal. Here, outlier means the value which is out from the average values. So these outlier are detected and removed. Next is normalization or standardization of features. Here the features are standardized, means they are normalized. Next technique to increase accuracy of classifier is optimize hyperparameters. Here we use the correct combination of configuration setting. The hyperparameter is called the configuration setting. And when we optimize this, that means we are using the correct combination. In the model, there are some settings by which the model perform good if we are having the correct setting. So we try different settings and take the correct one so that we can optimize the performance of model. There are various hyperparameters which we can tune. First is regularization parameter. Next is learning rate. Next is kernel parameter. This is used for the SVM, which is support vector machine. The next is tree depth, which is for decision tree. So these are the hyperparameters or the configuration settings which we can optimize. The techniques to optimize hyperparameter are grid search and random search. Now we are learning the next technique to increase the accuracy of classifier, which is feature engineering. Feature engineering create new features and transform existing features. Here, by adding the feature or by updating the existing feature, the model or classifier ability is improved. There are various techniques for feature engineering. The first one is scale numerical features to a specific range. Here, if some features are out of range, they can dominate. So, to reduce that, they are scaled to a specific range. Here, we can encode the categorical variable into numerical representation. Numerical representation are easy to understand and work with. So the variables which work with category, they are encoded into the numerical representation. There are some examples of such encoding. The first is one hot encoding and second is label encoding. The next technique under feature engineering is create new features by combining existing features. Here the features which are already available, they are combined and new features are created. The example are polynomial features, and log transformation. Next technique of feature engineering is selecting most informative features. Here the features which are very informative means they give the useful result, they are only selected. The examples are correlation analysis and recursive feature elimination. Now the next technique to increase accuracy of classifier is data augmentation. Data augmentation increase size of training data by applying rotation, flipping, scaling and adding noise. Here the data is rotated, flipped, scaled and noise is added so that we can increase its size. And by doing this, we are having various variety of data. And through this data, we train the model, classifier or algorithm. It is having an advantage. By data augmentation, model can work with unseen varieties of data. So if there is a new data which is unseen or of different variety, model can work with that. Now the next technique to increase accuracy of classifier is model selection. Here we select the best model on the basis of complexity, interpretability and performance. There are various models in machine learning. So we have to select a model which is best, which is on the basis of complexity, means it is less complex. It takes less computing time. It is interoperable, means it can work with the different data and it is having good performance. Now the next technique to improve accuracy of classifier is regularization. Regularization reduces the complexity of model and create a simple model. Here it tried to create a simple model, that means which can work very easily, which takes less time. Here the advantage is it prevents overfitting. Here the overfitting means we are keep on adding more and more features into the model and because of that the performance of model reduce and model become more complex. So we prevent overfitting because we are making a simple model. Now the next technique to increase accuracy of classifier is ensemble methods. Ensemble methods combine multiple models to improve predictive performance. In the diagram we can see that we have input training data. This is divided into different parts. Each part is given to the different model. Here we have model 1, 2 up to n. These models are giving their own prediction. It's like model 1 is giving prediction 1, model 2 is giving prediction 2 and so on till prediction n. Now these all predictions are combined and we can have accurate prediction. So in ensemble methods, multiple models are used which are able to improve the predictive performance. Here the example is combine the prediction of decision tree, support vector machine and neural network for better prediction. Here the decision tree, support vector machine and neural network are three different models and their predictions are combined so that we have better prediction. Now the next technique to increase accuracy of classifier is error analysis. So first of all, analyze the errors of classifier. So whatever the model we are using or the classifier we are using, we have to find its errors. Then we have to identify pattern. From these errors, we have to check some pattern. Means for which input our model is not performing good and what are the drawbacks for some specific input and make improvement. So from these patterns, we have to retrain the model and we have to provide the improvements. So here we analyze the errors, then we find the pattern and we make the improvement in model. So these all are the techniques to increase accuracy of classifier or model or algorithm. So that's all for today. Thank you.